Typically, those comets are big chunks of frozen water that get mixed up with various rocks and dust and gas and stuff out at the edge of the solar system. And then as that chunk of ice starts to get closer to the sun, it warms up and begins to melt. Now, in the vacuum of space, this process is technically known as sublimation, because it's impossible for liquid to exist in a vacuum, so the ice transitions directly into gas, and that's what makes the big, bright, fuzzy halo around the comet, technically known as the coma. And this is important because our typical water-ice comets will not get warm enough to sublimate and develop their coma until they pass through the orbit of Jupiter and start approaching the asteroid belt. But when TESS first saw 3I Atlas on May 7th, the object was still way out on the other side of Jupiter, and yet it was already super bright and getting brighter every day, indicating that sublimation had already begun. And based on this conversation, we know that if 3I Atlas is a comet, then it's much different from any comet than we've seen before. It's even wildly different from Oumuamua, which was infamous for showing no visible signs of sublimation at all. No coma, they're like opposites. And it's also different from 2I Borisov, because Borisov did all of the usual things that we would expect a comet to do, so it was strange in how familiar it behaved for something so unusual. But as we continued to observe the approach of 3I Atlas over July and August, it kept getting weirder. The coma around the object began to form a tail, which is normal for a comet, but the one around 3I Atlas started growing in the wrong direction. It was pointed towards the sun. We know that the sun is the primary source of light, heat, and energy in our solar system, but we also have to think of the sun like a big fan. It's constantly blowing out solar wind, and this is typically what shapes the tail of a comet. The solar wind blows back the rapidly expanding cloud of gas and dust around the chunk of ice to create a long trail. It's like when a dog sticks their head out the window of a car and air pushes their face back. It's adorable. Now, try and imagine if the dog stuck their head out and their face stretched forward instead. That wouldn't make any sense, right? And that's why people were kind of baffled when it started to look like the tail of 3I Atlas was forming in the direction of the sun against the solar wind. These are just some of the many questions that astronomers were trying to answer when they made the decision to point the world's most powerful space telescopes directly at 3I Atlas. That includes Hubble, James Webb, Sphere X, which is this crazy cone-shaped satellite that studies the origins of the universe, and TESS was also brought back in to take a second look at 3I Atlas as well.